Hi guys, in this video we're going to be going over cow gymnastics. So in this problem, in order to improve their physical fitness, the cows have taken up gymnastics, and Farmer John designates his favorite cow, Bessie, to coach the N other cows and assess their progress. Blah 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 blah. And then in each of K practice sessions, Bessie ranks the N cows according to their performance. And afterwards, she's curious about the consistency in these rankings. And so a pair of two distinct cows is consistent if one cow did better than the other one in every practice session. So basically, the cows are going to have numbers from 1 through n, and yeah, we can select a pair, and if the pair is consistent, then we're going to mark it because we need to help Bessie compute the total number of consistent pairs. So in the input, we're given k and n. The next k lines will contain integers 1 through n in an order, and it'll basically indicate the rankings of the cows um, identified by the numbers 1 through n. And if A appears before B in one of these lines, that means that cow A did better than cow B. So, for example, 4 appears before 1, so that means that 4 did better than 1. So, let's look at this problem in the way that we want to use our algorithm to solve it. So, we're going to pretend to be the computer here. So, what I'm going to do is I'm going to check pairs 1 and 2, 2 and 3, 3 and 4, sorry, 1 through 2, and then 1 through 3, and then 1 through 4. And then I'm going to check pairs 2 and 3, and then 2 and 4. And then I'm going to check pair 3 and 4. So as you can see, I'm just doing a complete search, right? So let's check pair 1 comma 2 first. 1 does better than 2 here, 1 does better than 2 here, but 1 does not do better than 2 in the final one here. And then 1 comma 3, 1 does better than 3, 1 does better than 3, 1 does better than 3. So since it's consistent, we're going to add 1 to our counter, and as you can see, it is one of the consistent pairs. Finally, we're going to do 1 comma 4. 4 does better than 1, 4 does better than 1, 4 does better than 1. We add it to the consistent pairs, now we have 2. And then we can move on, so 2 comma 3, right? That's going to be our next pair. 2 does better than 3, 3 does better than 2, so immediately it's not consistent. 2 and 4, 4 is in the beginning of every single ranking, right? So we know that 4 is going to be consistent with every number. So 4 is better than 2 in all three of these, so we add that. And finally, 3 comma 4. 4 is better than 3 in all of these, so we can add that. So in total, we have 4 consistent pairs. Um, so yeah, basically we're just trying to complete search through every single possible pair combination, and we're trying to see if it's consistent, meaning that one of the numbers in the pair is always greater than the other number in every single ranking that we're given. And we have k lines, so that's k rankings. And now we can move on to the programming portion of this video. Okay, guys, so just remember that for our static variables, we have n, which is the number of cows, and we have k, which is the number of lines, or what I like to call like logs of the rankings, right? And then we're going to store all those rankings in a 2D array. And then finally, we're going to store the pairs that are consistent in this array list called pairs. And so we create our in, our out, call our methods, close the in and out. And then we have our initialize method here. We're going to take in k, then n. Then we're going to set up rankings. Then we're going to initialize pairs. And then we're going to set up rankings, right? So pretty straightforward stuff. You can feel free to pause the video and just look at this code if you need to. Yeah, it's pretty straightforward, so I'm not going to go in depth into it. But for our solve method, basically what we're going to do is we're going to have count, which is our answer, right? It's going to be counting the number of consistent pairs. And then we have two booleans, all big and all small. This is going to be what checks our consistency. So basically, if we have a pair of numbers, and in all of the rankings, right? I'm going to call it logs from now on. In all of the logs, if we have one number being bigger than the other number, we're going to say all big. And then if one number is always smaller than the other number, then we're going to say that it's all small, right? So basically, we have nested for loop right here, and that's going to be creating the pairs. So we're going to start with 1, and then we're going to do I plus 1, right? So that's going to be checking for the pair, if the pair 1 comma 2 is consistent. And then A is just going to keep going forward while I stays the same. So it's going to be 1 comma 2, and then 1 comma 3, and then 1 comma 4. And then we're going to move I up 1, and it's going to be 2 comma 3, and then 2 comma 4, and then it's going to be 3 comma 4, and then yeah, that's where it ends. But basically, what we're going to do is, so um, we have all big equals true here, and then we have all small equals true. And so basically, we're going to set these true, and later, if both of them become false, then that means the pair is not consistent. So for now, we have to reset our values, right? Because we're working with a for loop, and you guys get the idea. So basically, what we do is we have this for loop, and this for loop is going to go through all of the logs. So each log that it goes through, right, is basically one line of k, as you can see here by the constraint. And so what we're going to do is we're going to get the first number, right? So that's going to be I, and then we're going to find it in whatever log we're looking at. So we could be looking at the first log, and what we're going to do is we're just going to use this method to find the index of it. So if you look here, this method takes in an array and it takes in a value, and so it's going to set its k equal to 0. And then what it's going to do is it's going to do a for loop through the array. And then if the array's current value equals the value we're looking for, we're going to return I. We can't exactly return it inside this for loop because we always have to return something outside. So all we're going to do is just set it equal to I inside here, break the for loop, and then return it here. And then basically, once we have the indexes of both the numbers in the pair, what we're going to do is first we're going to check if first is greater than second. And if so, then all small is false, right? Because first is this number is greater than the other one, so the number always being smaller than the other number will be false, and vice versa, right? So basically, um, if what we're going to do is we're going to do this for every single log, as you can see with this for loop. And then finally, if if the if both of them are false by the end of the for loop, then it's not going to be consistent. But if one of them is still true, right, then that means that it's going to be consistent, and we're going to add 1 to the count. Because it's either going to be always bigger or always smaller. It can't be both. And sometimes there's going to be cases where um, both of them are not true, right? It's going to be bigger sometimes, it's going to be smaller sometimes. So as long as we have one instance of it being true, right, one or the other, then we're going to add 1 to our count, and that means it's consistent. And then finally, once we gather up our all of our consistent pairs, right, um, we're just going to print it out to the count, or sorry, print it out to the output. And this is basically it. So now we can go ahead and submit. As you guys can see, it gets all of the test cases right. If you have any questions or any problems with Cow Gymnastics, feel free to leave a comment. And thank you for watching until the end.